Hi everyone, this video is an exercise 9b question 12. So, a surveyor wants to determine the height of a building and she measures the angle of elevation of the top of the building at 2 points 50 meters apart on the ground. Now, in part A, we want to use this information to determine the height of the building. Okay, so this is an interesting question because essentially this is a modeling question and we need to be careful about this because in this question, since this is a modeling question, we can, or actually, we need to make some assumptions so that we can solve the question. Because remember that modeling is all about assumptions, right? Without assumptions, we can't really solve modeling questions, or they can be extremely complicated. But modeling them and using some assumptions help us a lot to simplify the problem. Anyway, I will explain that more when we get to that point of the question. So first, the first thing is that remember that we want to find the height of the building, right? So one possible approach here is to just simply find this angle, which is 180 minus 52 degrees, and that is equal to 128 degrees. Also, let's work out this angle as well here. So we do 180 minus 40 plus 128, and we get 12 degrees. So the whole point of doing this was that since now we also have this side length from this point to this point, which is 15 meters, we can now work out this sort of the hypotenuse of this right angle, or at least the right angle looking triangle here. So we can use the sine rule now. So we can call here say a, and we can now write sine 120 over a is equal to sine 12 over 15. And now we just need to rearrange this, and we get 15 sine 128 over sine 12, and now we just work out, and we get 56.85, and well, I'm going to use the exact value for the next part. So that's basically this hypotenuse. Now, earlier I mentioned about making assumptions. So we need to make two important assumptions here that from the question is kind of clear when we look at the diagram. That first, the building is vertical, and also the ground, at least from this point, so this distance specifically, is horizontal, or maybe the entire distance. So now remember that if you have a horizontal line and then a vertical line joining that, then that means here is 90 degrees. Therefore, this big triangle here is a right angle triangle. And if it's a right angle triangle, then we can use basic trigonometry to find the height of that. So we can basically do sine 40 is equal to, so the height, which is what we want to find, over the hypotenuse. And we've already found the hypotenuse in the previous part. So therefore, the hypotenuse is simply equal to the answer times sine 40, and that is equal to 36.5 meters to 3 significant figures. And even part B is just saying as state one assumption made by the surveyor using this mathematical model. So yeah, one assumption is that basically the ground is essentially horizontal, which I just mentioned in the previous part, and that's just because this allows us to treat this as a right angle triangle and makes calculations easier.